Good afternoon to everybody, and thank you so much for joining this particular webinar and the panel discussion. To all the people who have joined from various parts of the country.
Just a minute. Himanshu, please let us know when we are going live.
Oh,
right,
okay.
ma'am. We are live. We can go ahead.
Okay. Good afternoon, everybody. Once again, this is Ramanan. I'm the Mission Director of Atal Innovation Mission, and I'm greatly happy that all of you have spared your valuable time to join what I think is a very, very important thing to discuss. It is about water challenge that we have launched jointly with the Danish government, Denmark government. It is called the ICDK Water Challenge. There are 4 challenges that we have launched as a joint initiative between the government of Denmark and the government of India, with Atal Innovation Mission representing the government of India. And the idea is, as all of you are aware, water is going to be one of the main challenges in the years ahead. It is very, very important for us. Already many countries are reeling because of the lack of proper drinking water or availability of drinking water. Water is required in our city, parts of the country, in the agricultural landscape that we are dominated with. And it is very important for us to look at from a sustainability point of view, from the sustainability development goals that we are all talking about, and the preservation of our planet, beautiful planet. How are we leveraging technology? How are we leveraging emerging technologies like sensor technologies that are there, communication technologies, satellite technologies? How are we leveraging digital dashboards and digital systems to create a smart agriculture or smart water management? How are we ensuring that the challenges that our farmers are facing in a predominantly, we have 44% of our country in India agri economy base. We have 1.3 billion people in our country. We have 715 districts, and we have over 4,000 small towns and cities. And if we are not able to ensure and the availability of water for the irrigation of our fields and the reduction in the wastage of water, all of these are paid attention to, it would be a torrid time for the entire population of our country and also for the population in the world. And therefore, as a part of the green economy, that both the prime ministers of the country, Prime Minister of India and the Prime Minister of Denmark, in their last meeting, discussed about how India and Denmark can collaborate from an innovation point of view to be able to harness the talent, the youthful talent of both the countries, to deliberate on the problems of water management, of a green economy the countries can promote, that the United Nations talks about, the 17 Sustainable Development Goals. How do we ensure that this partnership or the green partnership is able to benefit not only both our countries, but all across the world? And therefore, the Atal Innovation Mission has, together with ICDK, launched 4 challenges, which is open to both students from universities as well as to startups who already have a prototype of a solution for us to consider. So there will be winners are both are going to be people who have great ideas which can be converted into a working, viable prototype, and we have a set of awards for them. And there is a set of awards for the startups who already have a solution to address the 4 challenges that we are talking about. And as you may be aware, in this webinar, we had 2 of the challenges which were already discussed in detail. And in this particular webinar, we are going to be focusing on 2 other challenges that Ishita will be talking about a couple of minutes later. But I do want to share that Atal Innovation Mission is tremendously excited with this partnership, because this is the beginning of a long-term partnership with the Danish government, and to be able to promote innovation, collaboration between startups, between incubators, between entrepreneurs of both our countries, to be able to serve the needs not only of both the countries, but of the planet in general. And Atal Innovation Mission, as those of you who may have logged on for the first time, it is created by, it is a flagship initiative of the Government of India under the auspices of the Niti Aayog, which was flagged off by the Honorable Prime Minister 5 years ago in 2016. And the focus of the mission is how do you create and promote an entrepreneurship across the length and breadth of the country. And towards this end, it has launched several initiatives in a very holistic manner to be able to promote innovation and to create that ecosystem of entrepreneurship that will enable young, talented minds to find expression for their creativity and to be able to create startups. So at the school level, we have launched thousands of tinkering labs called Atal Tinkering Labs, which enables young students from grade 6 to grade 12 to get an opportunity to tinker with the latest of technologies like 3D printers, robotics, IoT, miniaturized electronics, augmented virtual reality, so that they can use these technologies to create solutions for problems they see in and around the community they live in, and thereby creating a problem-solving, innovative mindset rather than just a rote learning mindset. And this is very important if we want to create entrepreneurs of the future. So creating a culture of is first and foremost the most important criteria. And we back it setting up world-class incubators in universities and research institutions and the private sector across the country. We have launched over 10,000 tinkering labs in India, of which 7,000 are operational. Over 70 incubators have been operationalized in the last couple of years, with more than 1,600 startups, of which 500 are women-led startups. And the third thing that Atal Innovation Mission does is launch what are known as community innovation centers, so that they can address the needs of rural India and tier 2, tier 3 cities, and bring the benefits of innovation and spur not just innovation, but local job creation in communities, which is community-centric. For example, if you're in a tribal district or in a hilly district or in a coastal district or in a place like Goa, you would like to encourage, for example, the tourism industry, the fishing industry, the mining industry, or the shipbuilding industry. One of the 715 districts that we talk about that comprise India. And in order to solve problems that are having national impact at a socio-economic level, we launched what are known as Atal New India Challenges. And these challenges are both for the MSME startup community, as well as they are for individual innovators who can partner with MSME or with a large company. The idea is to launch these challenges in association with ministries or in association with countries. And this is an example of how we have launched, along with the Danish government, challenges in an area that is crucial not only for India, but for the world from a sustainability point of view. And whenever we challenges, it is not just an award that we give, it is an ecosystem of innovation and entrepreneurship that we provide to them. So they will have the ability to leverage our mentoring network, our incubator network, our venture capital network, our business planning strategy network, because a great idea does not become a great product or a great company unless you are able to bring together all these elements and stitch them together to convert this idea into a product, into a company that can serve the world. And therefore, we are very excited with this opportunity of executing these set of challenges with the Danish government. And now I'm going to, we are very happy that we have a very distinguished panel of speakers and a moderator who is going to moderate the session. And let me start off with Dr. Anitha K. Sharma. She recently joined the Embassy of Denmark in India as a counselor in urban development with a focus on water. Ms. Anitha, Dr. Anitha is a seasoned water technology and innovation professional with specialization in water quality monitoring, water treatment, wastewater treatment, water integrated water management, and resources reuse and recovery, all of which are very, very important in the context of the challenges that we have launched. And before taking her present role, Dr. Anitha served as a scientific officer at the Innovation Fund Denmark stationed in Copenhagen, Denmark, over 5 years. She's had a long fruitful association with the Denmark Technical University, where she earned her MSc and her PhD in environmental sciences. We are delighted, Dr. Anitha, for having us on this very, very important occasion. We are also joined by Dr. Vishwanath Srikantaiah, who is a water conservation expert known for his extensive work on India's freshwater crisis. He is the trustee of Biome environmental assisting communities in water and sanitation solutions. He is the director of Biome's Environmental Solutions Private Limited, which is an architectural firm specializing in sustainable design, and also the faculty at Azim Premji University. He has served as an advisor to RDM and Secretary General at the International Rainwater Catchment Association, IRCSA. He has worked with Housing and Urban Development Corporation, HUTCO, for 14 years before dedicating himself full-time to solving water issues facing urban and rural communities. Dr. Vishwanath, we are delighted and we are very privileged to have you here with us to be able to share your thoughts on this particular occasion.
My pleasure.
Thank you. We also have Mr. Manish Wasuja, a water, sanitation, and hygiene professional with a wide-ranging experience in policy planning, management, monitoring, and evaluation in water, sanitation, and hygiene sector. Mr. Manish has been with UNICEF for the last 15 years and currently serves as the WASH specialist at UNICEF Country Office, New Delhi, and provides the technical support to the Ministry of Drinking Water and Sanitation, Government of India, on water safety planning, water quality monitoring, and mitigation and disaster risk reduction interventions. He has served on deputation to the UNICEF Afghanistan Country Office and has provided support to Ministry of Rural and Rehabilitation Development and the Ministry of Public Health for establishing water quality testing and monitoring facilities in Afghanistan. We are indeed privileged, Dr. Manish Wasuja, for you joining us on this particular occasion. Thank you so much for sparing your valuable time and bringing your tremendous amount of expertise that you have gained through your various assignments in India and abroad.
Thank you.
And thank you, Doctor. And finally, we have Dr. Vandana Menon, who is going to moderate the session, right, Ishita?
That's right. Yeah.
Great. Dr. Vandana Menon is an architect with expertise in sustainable design. And for the last 25 years, she has undertaken numerous water conservation projects linked to social causes. She has worked extensively to conserve this scarce resource through architectural projects with various government agencies, such as the Center for Science and Environment, Jal Board, to name a few. She is presently the senior design architect at VM Architects and also holds a degree in architecture from Institute of Environmental Design. We are tremendously grateful to you, Dr. Vandana Menon, for joining us on this occasion and for agreeing to moderate a session of very exciting, distinguished, and accomplished speakers who are going to be part of this session. With that, I hand it over so that we can get on to the process of the webinar and have the people share their views, thoughts on the challenges, as well as what the innovators should be doing in these areas. Thank you so much.
Thank you, Mr. Ramanan. So like Mr. Ramanan mentioned, there are 5 challenges which have been launched. Out of these, 3 of them were discussed in the webinar we had last week, and we will share the link of last week's webinar or in the chat that everyone can refer to it, refer to that webinar if interested. The 3 challenges that were discussed in last week's webinar were digital water management solutions, solutions for monitoring and prevention of leakage in city water supply, and solutions relating to safe and sustained drinking water. The 2 challenges that we are going to discuss today with the help of the knowledgeable panel of experts we have with us on this webinar today. The 2 that we're going to discuss today are around wastewater management across the rural as well as the urban settlements. And the last challenge is around city rainwater harvesting. Over to you, sir.
Thank you, Ishita. So with that, may I request Dr. Vandana Menon to start the session and the moderation with the various speakers, and probably they can speak a little on the topic. But I leave it to you, Dr. Vandana, for guiding the session along.
The doctor part of it, I'm not sort of in the same league as some of our other panelists on the board today. But yeah, just to sort of start with what we're trying to achieve in this webinar. Of course, you all have the agenda, but to discuss the components of the challenge areas, the two challenges that we're going to discuss over here was just described by Ishita. And of course, along with this, that what we're discussing among ourselves and in this dialogue must assist the applicants in understanding. So I think that's really what we're primarily going to focus on, the nitty-gritties of the details of the actual application and challenge. I'm sure the organization will, AIM will share with all the applicants. So thank you, Dr. Anitha, Vishwanath, Dr. Manish, to sort of come on board for this discussion. Could I start with Dr. Anitha? If you could, tell us what all you'd like to cover, and then we'll make sure that we each touch on something that you're bringing to the discussion today.
Yes, thanks a lot for giving me the opportunity to talk to all these people. And as it was talked about me, I have been working within the water field for the past 20 years. And I really like the way work with the integrated water management, because they really put the water supply at the top level, and then they see how the remaining water uses can be looked upon. So because Denmark is the only country in the world which has 100% water supply based on their groundwater. So for them, groundwater is really very precious. And the way they also do is that they conserve the water, they try to maintain the groundwater level. And the issues like quota system, how much water you can use for irrigation, how much water you use for water supply, and all those kind of things. And also, I think sometimes people like to think that if you have a lot of water, then maybe you are in a good condition. Whereas in Denmark, they really try to reduce their water consumption. So the design water supply in Denmark is 110 liters per day, and lot as 135 or something here in India or other places where they really supply a lot of water, whereas in Denmark they are going on the other way. So they have a lot of campaigns and everything saying that don't use so much water, because saving the water is like getting the water also. So they have like integrated water approach, both on how the wastewater is managed, and how the rivers are managed, how the groundwater is managed. So everything is like integrated water approach. So they have plans for all the different water sources. And also with regard to wastewater, they don't see wastewater as a residue, they see it as a resource. So like everything like water, nutrients, and a lot of things. So they really look wastewater as a resource and try to come up with the next future wastewater treatment system. That is what they are going to design in Aarhus, for example. They are going to have a new treatment plant that is called Rainwater. So that will be functioning in 10 years. So that is how I also see in India that we have to, when you have this challenge, you have to think water as a resource and see all the different water resources that are there. And also when the groundwater is put into the planning, then you can measure how much water is there in the aquifers. There are a lot of technologies that are available for these purposes. So the innovative way of thinking both the rainwater harvesting and the wastewater is look at the water as a resource and try to plan it for the next 10 years. What is your water? And based on that, try to make both the regulations and the water charging and leakage detection. So everything is actually connected. That is what we look in Denmark. And that is how we we work in Denmark too. And it's an integrated part, both in the urban and in the rural sectors. Yes, and also under this Green Strategic Partnership, which we have just signed between Denmark and India, water is a very important parameter that is we are looking at. So we have both city-to-city collaboration in Udaipur, in Goa, and in Gujarat. There are a lot of places we are trying to work on this. And also we are trying to have some work on the water supply. So Denmark is considered as one of the leading within the water field, actually, and they want to be like, there is a lot of knowledge available in Denmark that can be put in India. So the way I see in this innovation challenge is not to bring the knowledge, but co-create something that can be applied for future, like in the climate scenario that is going to come in 25 years. Because everywhere there will be water scarcity, water quality will be deteriorating, and there are a lot of these issues that are coming up. And those are the challenges that is the globe is facing, and even Denmark is facing. So even though Denmark, there is a lot of water, they are also facing these challenges. So some kind of co-creation, innovation would give global solutions everywhere in the world.
Thank you very much. No, I mean, if you want to go ahead, please.
No, that's
okay.
Yeah.
Okay. Thank you very much, Dr. Anitha. So I think we're looking at continuing what Ramanan sir said about the fact that this is an ecosystem of innovation which we're assisting AIM with, and to borrow some of all the innovations that you mentioned which are already available in Denmark and see how we can apply them to the two challenge areas that we're looking at today. That's roughly what I've taken from what you just described. Yeah. Could I request Mr. Vishwanath, would you like to maybe pick on a few salient areas for these challenges that you'd like to focus on today?
Pleasure, Vandana. Thanks for calling me Mr. and not Doctor, and sort of recognizing that I'm not a doctor. Keeps yourselves.
We're in the same boat. We're in the same boat.
Mr. Ramanan is very generous, right? It's your gray hair and my long beard, right?
Right.
So
right.
That's the doctorate thing. So Vandana, I had the pleasure of being escorted around and shown the rainwater harvesting system in your colony pre-COVID times.
Yes, it was a while ago. Yeah.
So we have some association with rainwater harvesting. So let me just talk about the two topics of the challenge that we have: rainwater harvesting and wastewater reuse. And the one other point which I want to preface is that I'm sure that the Danish students and the Danish entrepreneurs will be engaged as part of this collaboration. We learn a lot from the Indian challenges also, as much as we learn from Denmark. I think the opposite learning will be also something which will be fantastic as things are co-created, right? Because the challenges here are unique. I was just checking the population of Denmark. It's about half the city of Bangalore, right? So scale and population is one issue, and therefore managing resources is a big challenge. But let's get to rainwater harvesting. As many of the participants will realize when they want to pitch in, is that it's an ancient technology, it's an old tradition in India. It's been going on for centuries. The challenge now is how do we modernize it? How do we adapt it to the current demand and the current scenario? So typically, rainwater harvesting has two different components. One is rooftop rainwater harvesting, where you take rainwater from the rooftops and you either collect it and store it in tanks, or you recharge the aquifer, right? So this is one component, rooftop rainwater harvesting, and the other is the broader water harvesting, which can be done, let's say, in fields and farms and in open areas and playgrounds. So I'll just focus on the rooftop rainwater harvesting a bit here. It has key components. One is the catchment, right, which is the roof itself. And so one of the challenges, how do we ensure, how do we predict rainfall so that we are able to keep the roof clean? Keeping the roof clean is a big challenge in the Indian context for a rainwater harvesting system. Because if you have a clean roof, the quality of your rainwater improves dramatically. The second component of rainwater harvesting is conveyance, the pipes, the rainwater pipes, or what are called PVC gutters for a sloping roof. Now, here there's a challenge in the Indian context. How do we design gutters which are self-cleaning? These gutters tend to accumulate leaves, silt, dust, bird droppings, and certain other things. We don't have a technology, or we don't have a system of self-cleaning gutters. That's something to think about. The third component is something called a first rain separator, which separates the first 2 millimeters or 3 millimeters of rainfall, because this is the rain which brings down the dust from the atmosphere or picks up the dust from the catchment area when it runs off. Right? So this first rain separator. Immediately attached to the first rain separator is a filter. And here's where the innovation is necessary. Can we devise low-cost filters, rooftop rainwater filters, which can do the job of first rain separation and as well as filtering the water so that it has no organic components or organic sediment. Then it goes to a storage system. Now, in the storage system, this is the costliest component of rainwater. Storage is the costliest component. How do we devise or design low-cost storage systems which can harvest rainwater and collect it and keep it for long without getting spoiled, but make it cheap and easy to install? Then the last component in the Indian context is recharge. Again, when we recharge, can we devise recharge systems like recharging a bore well or recharging an open well, where the water will be filtered and the recharge rate can be measured? How much water are we putting into the ground? This is something that will help designers to better manage water. Amongst all this, the quality of rainwater is a signal that needs to be sent to the household. You know, in the Indian context, there are 66 million people, and Mr. Wasuja will point out later, I'm sure, 66 million people who are susceptible to fluoride contaminated water, to drink fluoride contaminated water, and about 18 to 20 million people who may be susceptible to drink arsenic contaminated water. Then there is nitrate contamination, there is iron contamination, salinity contamination from most of our groundwater systems. Now, these households need just 7,600 liters of good, clean water in a year, 20 liters of water a day. 7,600 liters of water. If they're able to get this from rainwater, which is free from fluoride, arsenic, iron, and if treated, can be potable water. If that is done, then roughly about 80 million people or 90 million people can benefit from the bad effects of contaminated water. That's at a lower estimate, right? Though the other components of the government, the Jal Jeevan Mission is seeking to deliver pipe water supply. But for the moment, we can think of rainwater harvesting as a very critical supplement for potable water also. That's something to think of in the rainwater harvesting designs that you approach, right? IoT of things in terms of predicting rainfall, IoT of things in predicting quality of water, simple systems of filtering and treating water, rainwater for adequate quality, simple systems which can be installed in small rural homesteads, even in flood-prone areas. Rainwater harvesting provides water which is clean from flooded water because all the areas are flooded and there's no clean water available. So even there, even in flood-affected areas, rainwater harvesting is an important role. Now coming to wastewater. Now, as more and more water will be pumped into our homes in India through the Jal Jeevan Mission and other pipe water supply schemes, and as cities invest a lot of money in bringing pipe water, the generation of wastewater will keep on increasing. Now, there are two components of wastewater. One is the industrial wastewater, and we will not talk about that. The other is domestic wastewater. Luckily for us, domestic wastewater is rich in nutrients. It has pathogens, but it is rich in nutrients. If you're able to get rid of the pathogens in the wastewater, then this water is immediately and easily available for agriculture, right? For growing kitchen gardens, for growing terrace gardens, for large-scale integration with the agriculture system around small towns and cities, and even in our villages. Even villages which will generate wastewater. If simple treatment systems are available, then that water will become precious water for agriculture use, right? So potential for solutions is absolutely stupendous, and I'm really excited that all of the participants have this unique opportunity created for them to present a solution and take forward this as a business opportunity, right? With knowledge coming in and be co-created. Wonderful opportunity. Approach it with some passion, and I'm sure you'll find a heck of a lot of solutions. Thanks, Vandana.
Thank you very much, Vishwanath. I think you've covered very, very comprehensively all the areas that we're looking at for rainwater harvesting with, each of the stages that has potential. And of course, bringing us down to the most critical stage, maybe the one which is most untouched or most urgently needs an intervention. Similarly, for wastewater management, I think it's past the time we should have realized that water is not a single-use resource anymore. That if we don't wake up to, like Anitha said, being able to understand that your wastewater is a resource, we're going to be in a lot of trouble. So I think that again area which you've explained very clearly, both for the agri-belts and the rural areas. In the urban areas too, we can, begin to figure out the potential or the capability to design something for the urban areas, but certainly for the rural and agri areas, there's immense potential. So thank you very much for that. Dr. Manish Wasuja, could I invite you to do something similar? Just touch on the points that you'd like to discuss, and then we can all get into an open discussion.
Yeah, thank you. Again, I'm not a doctor, so
okay.
Yeah,
right.
I'm an engineer by profession.
Right.
But
right.
What I want to highlight here, the challenges which are being listed here, rainwater and wastewater, both are actually right now very important in the given context when Jal Jeevan Mission is promoted in rural areas. Every household will have, every family will have water at the rate of 55 liter per capita per day. That means if we just calculate as a thumb rule that okay, 70 to 80% will be wastewater, it can be grey water as well as black water, then you just think what is the amount of water which is going to get out of that household and from household. So far people were having hand pumps, so there was some kind of community level treatment system which was installed by panchayat, but now to treatment, and that is very important for us to understand. In situ treatment at household level, in situ treatment at community level, or it can be a combined system at community level also. So I'm just giving few examples like what Mr. Vishwanathan said. There can be kitchen gardens, can be one technology for use of wastewater. Simple, easy to use, practical, cost effective technologies which can be built under different GP funds, using GP funds, because now we have 50% of 15th Finance Commission funds as tied funds which can be used for both water and sanitation, operation and maintenance of water sanitation infrastructure. So we should be able to give some cost effective treatment or solutions, technological solutions which are easy to be adapted by a household, a rural household. We can talk about whether it is rainwater harvesting at household level, rainwater recharge, as Mr. Vishwanathan said. Grey water and black water, as I said, are the components of wastewater. We should be very clear in saying what will be the treatment. If we are talking about treatment systems, then what will be the treatment system of grey water and what will be the treatment system of black water. Right now, both of these are being treated in a combined manner, and that creates problem. Black water as such is very less as compared to grey water, and the technology which is required for grey water treatment is also very easy. But when it gets mixed with black water, then the entire water becomes black water, and it needs more kind of technologies for treatment. So we should be very clear when we are telling any solution. It should be adapted to rural and urban scenario as the case may be, for a household to understand what is the importance and why should they focus on that. Because if I am getting water at 55 LPCD today, if I don't talk about recharge or rainwater harvesting or sustainable water availability, I will not be getting that water tomorrow or maybe in the coming years. So wastewater treatment and rainwater are actually sustaining the availability of water, of fresh water primarily, because it will not only mitigate the water security issues but also water safety issues, water quality issues, arsenic, fluoride. When we talk about rainwater harvesting, these are one of the mitigation options. They dilute the availability of arsenic and fluoride to the reasonable level which can be potable. So I am open to kind of having any questions or clarifications.
Thank you, Manishji. I think that kind of, again, encompasses clearly what you're saying about the doability or the requirement in these two areas of an intervention. From my side, I think one of my concerns when I was talking to Himanshu earlier was we should attempt to ensure through our engagement in this process that unless it's the next generation, we're not taking on board an idea which is a reinvention of the wheel. Because I think when you say across the board, especially when Anitha talked about what's already happening in Denmark, there's so much to borrow from and learn from. Our domain knowledge of our geographical area of where we are is something that probably allows us to adapt something which exists to what works for us. So I think for me, it was that we, like we said, rainwater for us is an ancient knowledge. We need to contextualize it to today and today's problems, but I don't think we should try to get to something which becomes merely an innovation which is a reinvention of the wheel. The second one that I was concerned about for both really was when we talk about the urban context is retrofitting. One of our major challenges today is some of our policies are actually being implemented retrospectively, and therefore retrofitting is a big challenge. That hopefully a lot of what we're talking about that comes out of this whole exercise is something which has that one paramount thought or idea which is implementable to ensure that they can be retrofitted. And like you all pointed out, I think going ahead with the Jal Jeevan Mission targets and agenda, where we're looking at depending on groundwater in a lot of these urban areas to be the only source of piped water being supplied. The need for the treatment, which you talked about, as well as the approach or the understanding that this 55 liters supplied to you needs to be reused. Finding appropriate uses, treatments, and uses for those is, I think, something that we need to, because as policy is changing at the national level for us, we've got to try and be ahead or at least match up to it so that we have efficient solutions for this potential of a lot of wastewater which is going to be generated once the Jal Jeevan Mission is in place. So taking it further, I think some of the points that we've already discussed in the previous webinar and which maybe we can refresh over here is scaling up and affordability of what we assist everybody to come up in among these ideas so that the water solutions are actually applicable finally once, through the hands of the incubators. And it doesn't become a selective technology for a few, but is available to the maximum people. So I think recapping on the two areas, rainwater harvesting and wastewater, both for agri as well as for rural and urban, a lot of points have been put on the table. Ishita, I'm assuming that you're also sort of tracking them. And we can, if needed, between ourselves, take up some of our or each other's thoughts and elaborate on them. Maybe, Anitha, some of the technologies or some of the approach to how one uses water in Denmark. If you feel that what Vishwanath has, been talking about, or Manish has, is something that you feel ties very well or is applicable, just please let us know.
I think all these things fit very well together. It's how you think about things, right? Because like rainwater harvesting has been done for a long time from the roofs, but also you can do on the ground also. So there are a lot of ways of thinking how we can do these kind of things. And also, so my approach would be like make the people realize water as a resource. Yeah. And as soon as they do that, I think it will come automatically both in the agricultural sector, but also in the rural sector. Because I was talking to a farmer the other day, and what he was saying is that flowing water is a status symbol because they never used to have this kind of thing. So they just want to let the water flow rather than having drip irrigation.
I lost the audio.
Can you hear me now?
Yeah, we can hear.
Yes, we can hear her fine.
Okay, thank you. So because the farmer was telling me that I would rather have the water flowing rather than having drip irrigation where you can really consume the water where it is required. So I think it's a like socio-technological innovation that has to come so that we really can reach the goal of Jal Jeevan Mission. So there are a lot of things that have to like come into place together, and the affordability and the water quality and people's perception about how to use the water and the water plan, so that we know that groundwater is not what you call a resource that is there forever. If you don't look after it, then it will vanish in some time.
Right.
So all these things we need to have people's perception, people's understanding, and then based on that, the planning, the policy, the governance, along with the technology and the social innovation, that would be the way ahead. That is how I feel, because I was also working on the Bengal Delta on arsenic pollution. I did my PhD on that actually, just to be sure. Yeah. So it is like how you make people realize that water is a resource,
Right.
and then have the right policy, and also maybe the tariff system. We have to find the right model for India, so
Correct.
that it becomes affordable and it becomes like people take it as their own. I remember when I was in India, I'm from India. When I was in India, I used to use the water as if it's just something that is coming. Whereas in Denmark, if some people does that, I mean, when I have visitors, I just after them all the time, don't waste the water. It's not because we don't have water in Denmark, but it is very expensive to have the water in Denmark. So
Right,
that is
right.
the way I think could be like having all these things in one go,
Right.
and make people realize.
Okay, thank you.
Yeah.
Vishwanath, Manishji, tell me, do you think that among some of the things we are talking about, since we're talking about smart cities and the implementation of these technologies for water, with water, digital tools to actually cover some of the areas that Anitha just talked about, is that potential, or should we really be looking at sort of hard, tangible stuff?
Manish.
Yeah, thank you, Vishwanath. I think digital is not separate from any technology. When easy of the solution, then it has to be digitally linked, because it has to serve the masses, and you should be able to take decision based on the system, based on the information you are getting from the system. So that kind of acts as a tool also to take decision, whether at household level or at community level. I can give you a simple example. If I know that the water source which I am using for getting water at my household level has only reserved water for next 20 days, I will be worried. I will be thinking about how I can rejuvenate that water supply, water source. So I has to feed to improve waste minimization, water waste minimization, even rainwater harvesting. So that has to be there. But when we are talking about digital connect or digital transformation, it should also be simple to use. It should not be very complicated.
Yeah.
So that is from my side, and Vishwanath, please come in.
Yeah, so I just quickly respond one of the points you made about retrofitting also. Half of urban India is yet to be built.
Yeah.
So there is a component of retrofitting, but we are fast urbanizing and a lot of reconstruction is happening, right? So the potential for the future in itself is such a large market that entrepreneurs need not worry about retrofitting alone or the new construction alone. They can pick or choose, and they can be still in business and making money. Even a city like Bangalore, when we made rainwater harvesting compulsory as part of the building bylaws, it has resulted in about 150,000 buildings doing rainwater harvesting.
Correct.
It spawned an entrepreneurship. More than 40 different kind of filters became available in the market, right? So creating a market is a different thing, but responding to the market is also important, because only the products which are in India, cost is a key determinant. Quality is second, right? So the entrepreneur will have to think as to what the market demands and what the market is willing to pay for. And I'm sure the youngsters will find their way around, given the incubation that will go into that, right?
Right.
But but what we have to also focus on, and for example, in Denmark, we had this opportunity to work with one of the largest pump manufacturers in the world. It's a company based out of Denmark, right? Called Grundfos, right?
Yeah.
So the discussion with them was very interesting. Now the pumps which are put into aquifers are merely extractive devices, right? The more efficient you make the pump vis-a-vis electricity, the more water you're able to pump out. Right? So one efficiency in energy means depletion of aquifers in the other side. So can the pumps become indicators of the water quality and quantity available in the aquifer? Can they be not merely extractive devices, but also informative devices? So there are new ways of thinking that Denmark can also pick up, that India can also pick up. Can our pumps also not tell us how much water is there in the aquifer, whether the aquifer has fluoride or arsenic in it or not? Should it be only left to us to test it in a lab or to do some other tests on the ground? Can it not be automated? These are the kind of new ideas that will need to be thought through with the participants. And I'd encourage the participants who will come in for this contest to do a quick web search with the IWA, the International Water Association, where this whole thing will be presented in Copenhagen in May or whenever the conference is. The IWA has a website, and there's another one called Sustainable Sanitation Alliance, susana.org. It already documents a whole bunch of innovations which have been attempted in wastewater, and the IWA website will tell you something about rainwater harvesting, right? So as you were pointing out, no need to reinvent the wheel. Let's learn from those quick experiences on these two places, and let's then build on it for us to go forward. There's a company and a startup in Bangalore, because it's mandatory for a set of 20 flats and more to have their own wastewater treatment plant in Bangalore. And you have to have zero liquid discharge. That is, you have to reuse all the wastewater within the building. So there's a company led by a young entrepreneur, which actually takes wastewater and turns it to drinking water standards. And the first set of flats in India, called TZ, about 94 flats, are actually drinking their own wastewater. So many barriers are being broken, many innovations are happening, and there is huge potential. If you're able to break through many barriers, marketing is one, psychological barriers are the other. Technology barrier is not the most difficult. The technological barrier is usually the easiest, right? There are other challenges. But I tell you, for the participants and for everybody, if you're able to pursue an idea, the sky is the limit. There is so much that can be achieved with water and wastewater. There's no limit to it. The last bit of advice, Vandana, for them is try and seek a good mentor. Right? Try and see whether you are able to go to the IITs, for example, or for the other agricultural college, and get a good mentor for yourself who will be able to better advise you, and you'll be able to crack this.
Thank you very much. I think that sort of encompasses a lot of the probably doubts going around in the minds of some of the participants. And I think, Hanji, please.
I have one comment about this quality versus affordability, because in Denmark, they have this life cycle cost of a product built into the price of the product, actually. So like in India, maybe we say that it's like the procurement, like only the capex, whereas the other places we also have the opex, like operation and maintenance of the cost. So it's the whole life cycle. So sometimes if you only look at that, how much a product will cost, that may be like very cheap in the beginning, but it might be very expensive during the lifetime. So that also have to be considered when you develop any product, actually.
Yeah, Anitha, that is the ideal state that we have to reach, and there's no doubt that we'll have to reach that. But also the participants will have to realize that the Indian market is maturing, right? There are various spectrums of economic players here, from the least affordable to the highest affordable. So depending on the niche that you want to target, you'll have to be a bit realistic about it and take it forward. And you should ideally aim for life cycle cost assessment for sure, but perhaps there's a ladder up to it, right? And you have to be realistic on that score.
Yeah, that is what I'm saying, because life cycle, we don't need to have a life cycle of 50 years. If you can use it in 5 years. I mean, that is what you have to like really think about, that how long time you are going to use it.
Yeah,
I
think if there is in terms of the hours used, or in terms of the notional cost return on the investment in the product, I think that should justify it.
This is the era of built-in obsolescence. People are making products to go redundant in 1 year or 2 years, unfortunately.
Absolutely.
Whereas in the Indian market, you have to think through as to what people value, and they want it for a lifetime. Right?
Quite right.
Yes.
I think the lifetime of a technology may be shorter, but of the product is expected to be much longer for the Indian scenario. Maybe not so much the market, but certainly for the scenario. Ramananji, anything that you would like to add to this while we're discussing? Otherwise, we can recap. I don't know, Ishita, are we close to when we should be winding up? Have I eaten into everyone else's time?
No. I think it's been wonderful, Dr. Vandana or Miss Vandana. Thank you so much for steering the discussion in very, very interesting areas. And I have actually taken a lot of notes as the speakers are talking. I think it's a constructive discussion, and it has given a lot of food for thought for all the listeners and the audience, and particularly the young innovators, because as Dr. Anitha pointed out, water is such a precious commodity.
It is.
Imagine we are searching for planets with water. That is what NASA's expeditions are all about, and Elon Musk talks about. Where can we find the potential for life in another planet? This is one of the most precious commodities that we have. That is what defines the earth. That is what defines life in it. And if we are not careful about water, and if we don't treat it as a very precious commodity, as people in Denmark are already doing, and as Dr. Anitha was suggesting, it would be our planet to lose. And imagine if for one day there is no water supply in your house. What happens? I mean, all hell can break loose. You don't have drinking water, we don't have water to and so on and so forth. You see the panic that arises when you don't have water. And there are many, many millions of people in India still. Out of the 715 districts, 115 are called as aspirational districts, which are at the bottom of the pyramid in terms of access to clean drinking water, access to clean sanitation, access to affordable housing, or access to ability for them to irrigate their fields because there is no water. I mean, you go to a place like Thoothukudi, where they are all dependent on the rain, and if it doesn't rain that particular year, there are movies made out of all of this stuff. And so this is a very precious commodity, and we all need, therefore, to respond to this challenge. The young innovators may be thinking, hey, what is this? Can't I do something like Flipkart? Why don't you put up a challenge like, can I create the next Ola or the next Uber? Water management, water reuse, water recycling, rainwater harvesting, water monitoring, digital dashboards for us to know exactly how much water we are consuming, how much we are wasting, how much we are recycling, ensuring that we are leveraging technology. Sensor technologies are now out there. IoT technology can enable you to actually, the Israelis are doing precision agriculture by sensor technologies, and they are just watering for the crop that is needed exactly the amount of water that is required. And that is all scientifically possible today. You don't waste any water in watering a field. And so when we talk of irrigation management, and India being 80% of fresh water is used in irrigating our fields, and they are so dependent on that. So how do we optimize on that? And I think Dr. Manish, he brought out that point very beautifully, where he said, not just digital technology that is going to make an impact in water management and in responding to this challenge. And this, any technology that can use, even satellite technology, so that you are able to find those spots where there is water deprivation, and how do we address that water deprivation, or where there is, there is a famine, or there is a flood. Both of these are very important for us to be able to see how we divert that water and not use that, that water doesn't get wasted. And then cleaning the water. Water cleaning is so important. I mean, India is dependent on all the rivers. The rivers are considered holy. The Ganges is considered as Mother Ganges. But if you go to Haridwar, you go to Rishikesh, you go to all of the places that the Ganges is flowing, it has become so polluted. So how do we, stopping the pollution and the impact that it is creating on the water supply, identifying sources across the country, so you know exactly the quality of water that is there, increasing testing mechanisms and testing efficiencies, finding whether there is fluoride or arsenic in the water. All of that is so very important. And as Dr. Vishwanath also brought out very, very well, when you talk of rainwater harvesting, it has created a opportunity for filters to be created in the marketplace. And so everything of this is dependent on, there is technology interventions which are going to be profitable if we are able to harness innovation and combine them with technology to be able to deliver all these solutions. So I think it has been fantastic, and also the references that you have given. I would urge all the participants and the innovators, the Sustainable Sanitation Alliance that you talked about, to read about that, or water to drinking, even waste water. I mean, I saw one of those YouTube videos, where I think Bill Gates has already been involved in seeing how you can convert wastewater into drinking water, and he actually drank some water, right? And I mean, that video shows all of that. But it's a very expensive solution that they have developed. How do we minimize the cost, and how do we make it affordable in a country like India with 1.3 billion people, and with 115 aspirational districts and 22% below the poverty line? We need to make sure that they have access, because just clean drinking water will eliminate 80% of the waterborne diseases, which is affecting so many people in the country. So you're saving lives. So fantastic discussion. I want to thank all the speakers and Vandana for guiding and steering this session. And it's been wonderful. And, and I do want all the participants to be aware. Please, it doesn't. Your is going to matter, and we are going to look at all the ideas submitted, all the innovations submitted, all the solutions submitted, and we will connect you to various stakeholders in the ecosystem. That's our job. That's what we are launching this challenge for. Not for saying that 4 of you won this challenge and photo op. This is not a photo op opportunity. This is a real opportunity for you to make an impact through your idea, to be converted into an innovation, to be converted into a product, to be launched into the marketplace, and to become successful. And our success of this challenge is only based upon your success of being able to convert your idea into a working product. So I do want everyone in the audience who are listening to this and who are desiring to participate to keep this at the back of your mind. We want all your ideas, if you know, to the ecosystem, so that you and blossom. So with that, thank you once again, Vandana. And if there is any closing comments from anybody, otherwise I will hand it over to Ishita for her final word of thanks.
Right. I think, Ishita, you can take it from here. I think Sir's encompassed everything that we.
Thank you so much. This was very, very insightful. It was a very candid and a very, candid discussion between a lot of knowledgeable people. I'm sure all the students and entrepreneurs who've logged in, who are aspiring applicants for this challenge, I'm sure they've got a lot of ideas around the innovation, the product, or the solution for which they can give us an application, around what is the resources which they can dig into on the internet for improving upon their suggestions that they need to send to us. So I would like to thank Ms. Anitha Sharma, Mr. Vishwanath, Srikantaiah, Mr. Manish, Wasuja, Ms. Vandana Menon for a great discussion. And of course, Jakob and Asta, who are from the Embassy of Denmark, who've been our constant support and partners in crime organizing this challenge. And Mr. Ramanan, who's the mission director of Atal Innovation Mission, constant support and source of motivation for all of us to keep doing better. And last but not the least, of course, Himanshu and others in the AIM team who are helping implement this challenge on the ground. Thank you so much, and I wish best of luck to all the participants. Thank you, everyone, for joining us.
Thank you, Ishita. Thank you very much. Thank you, Himanshu. Thank you, sir. Thank you.
And I'll definitely want to keep in touch with the panelists. I will write to you all separately. Thank you so much.
Thank you very much. Thank you.